One of the double replacement reactions that we'll be talking about are acid-base reactions. And just as a reminder, you need to have a hydrogen, an acid, as a reactant, and you need to have a base which ends with an OH as a reactant to create an acid-base reaction. So I have an example where we have sulfuric, let me get my pen going. So sulfuric acid with potassium hydroxide. And as we've done with our precipitate reactions, we first of all have to start writing our reactants. So we know that sulfuric acid is H2SO4. Just for me as a reminder, I know that this has a -2 charge, this has a +1 charge, plus potassium hydroxide is KOH. I remember hydroxide has a -1 charge, potassium a +1. Okay, so we know that an acid-base reaction will always create water, and we can look at it this way. So this is my A, because that's a cation. This is my B. This is my C. This is my D. And we know that in double replacement reactions, we have AD coming together. So in this case, we have H and then 2O. So for this one, because it's a covalent compound, you do not need to balance the charges because it's covalent. We just know that it's water. And just quickly putting down aqueous here, and when water is formed, it always becomes a liquid. So you will always write liquid for water when you have an acid-base reaction. And your products for this one are going to be KSO4. Just remember it has a -2 charge. This has a +1 charge, so it has to be K2SO4. And this here is CB. Okay? And then similar to what we did before, we're going to create a total ionic equation. And we more or less just separate the ions again. Okay? And in this case, because we have this being a liquid, we're going to kind of treat it as a precipitate. Okay? So we have here 2 hydrogens that have a plus charge, plus SO4, which has a -2 charge, plus, oh, and my apologies, I forgot to balance the equation, so let me do that right now. So in this case here, to balance this equation, I need to just simply put a 2 in front here and a 2 in front there. So then I have, in that case, 2 potassiums that have a plus charge, plus 2 hydroxides, which have a minus charge, and those react to make water, which is our liquid. And remember, we're going to write that together just because we're going to treat it like a precipitate, plus 2 potassium and 1 sulfate. All right, so then for net ionic equation, same thing as with precipitates, we're going to just cancel out which ones did not change. And so it looks like our sulfate did not change, so we'll cancel those out, and our potassium didn't change. So we are left with 2H plus 2OH to form, and in this case, I needed to put a 2 in front here, my apologies, 2H2O, okay? And that more or less shows you how to do acid-base reactions.